So lesson 4.3 is the unit circle. So, and throughout this whole chapter, we've already started learning small bits and pieces. We're going to really add on a lot and talk about how the unit circle works in lesson 4.3. Notice today I'm talking about lesson 4.3.1. We're not going to get all the way through this. And then after that, we're still going to have lesson 4.3.2. So there's lots to kind of grasp on. So as you have questions and whatnot, make sure you ask and let me, kind of try and straighten some things out as we go. Some basic vocabulary here, I guess I could say, is talking about the angles. And as we look at the angles on the unit circle, every angle is going to have an initial side and a terminal side. The initial side being the side the angle begins. So where are you starting to count? Terminal side, where you are starting to finish. Now, general rule of thumb, where does our initial side usually begin? Usually at 0. And do you remember where I said 0 was? Does it make sense if I say 0 is east? 3 o'clock. That's what I should use, 3 o'clock. Okay? Whatever So 0 degrees is over here at the 3. That is our initial side most of the time. That is where your angles start. From there, on a unit circle, general rule of thumb is that we will go counterclockwise. So you start at 0, and as you've already seen, if you follow the numbers, you go up and around to the left there. So counterclockwise. So initial side where you're starting, terminal side where you're ending. So if we begin here and say end up here at 60 degrees, 0 is your initial, 60 is your terminal side. Now, I was just talking about how when you begin at 0, which direction do we normally go? We normally go counterclockwise. That is when you start at 0 and move counterclockwise, you are counting positively. Meaning, I start here at 0 and I move counterclockwise, this is a positive angle. So if I start here and move over here, I'm moving over to, I don't know, what is that, around 150 degrees, 135, something like that. Because we're starting here and we're moving over there. Okay, so positive. When you're going counterclockwise, which is the forward motion, so to speak, that is your positive angles. Now, the opposite of that, if instead of starting at 0 and going up, instead if you go down, it's like going backwards. You're now counting in the negatives. So if I start here and start counting negatives, for instance, this could be referred to as negative 90. This could be referred to as negative 180. All the way up to, I don't know, maybe negative 210. I don't know exactly where that is. Okay, but those are negatives there. When you look at the unit circle, the basic labelings you're going to see are from 0 to 360 going in a positive direction. However, all of these angles have multiple names. Because keep in mind, if over here on a positive angle, I go from the positive direction and I get to say 150, but if over here I go from the negative direction, we would call it negative 210. 150 and negative 210 are the same angle, just going from different directions. And that's what we're going to talk about, that all these angles here have multiple names. They all kind of have a basic name, like between 0 and 360. But then there's also multiple ways to get them. And so you'll notice the vocabulary there of coterminal angles. Coterminal angles are those that start at the same initial side and they end on the same terminal side. So they start and end in the same places, but you get there different ways. So one option is they simply swing around the center more than once. In other words, I can not just go around once, but I can go around multiple times and just keep adding the degrees as I go. We can also, there's the difference of, okay, are we going to go the positive direction or the negative direction? And so those are coterminal angles. For example, 90 degrees, 450 degrees, and negative 270 degrees are all the same angle. Does that make sense? Let's do the visual. You guys know what 90 degrees looks like? If I start here, if there's my 0, how do I get to 90 degrees? Yeah, we're going to go counterclockwise, right? So we're going to go here, and so 90 degrees is straight up, yes? So that's 90 degrees. Yes?
The whole negative like 210 and positive 150. How do we know those if they're on this chart?
Okay. Hold on. Let me go through this. I think it'll make more sense. It all comes down to you have to be able to figure them out. Okay? But I think as we go through this and example 1, it'll make a little sense. Okay, so we're okay with 90. Okay, let's figure out where 450 is. So we still start at 0, right? You start that same initial side. 450. What's 450 mean? Think about it. What's going around a full time? What is that? 360. So if I go here, right there, I've gone around 360. What do you know about 360 plus another 90? 360 plus 90 is 450. And where did I just end up at? That same place, right? So do you understand how 90 degrees and 450 degrees are the same angle? Could we go higher? Could I add another 360 onto 450 if I wanted to? Yeah. Again, we could sit here all day and name angles that are equivalent to 90. Okay? Now, what about that negative 270? Okay, we're going to go the other way. So negative 270 says, okay, I'm going to start here and I'm going to go down instead. So as I go down, I'm first at negative 90. As I come over here to the horizontal, I'm at negative 180. And then where are we at? Negative 270. Does that make sense? If we think in terms of quarters, 90, 180, 270. So do you believe it now that those are all through the same angle? Okay. And as Chandler asked, you're only going to see 90 listed on your unit circle. And it just comes down to figuring the other names out. You can add 360 repeatedly. You can subtract 360 repeatedly. But they're all the same, multiple names there. Now, that was in degrees. Degrees is our comfort zone. Because degrees, that's basic numbers. That's what you've known for years, right? Now let's talk radians. Now I'm going to argue that pi, 3 pi, and negative 99 pi are all the same angle. So let's start with the basics. What does, okay, so let me draw 1 pi. What does 1 pi look like? 180? Because ways to know that. First of all, does it say it on the unit circle I gave you? Pi and 180 are the same thing, yes? Did we also talk about converting? How do you convert 180 to radians? You multiply by pi over 180. And so, right there is pi. In other words, going from 0 to 180 is going from 0 to pi. Now, supposedly 3 pi is the same. Okay, so count with me. If we start here, we go around the top half, we're at what? 1 pi? What happens when I go around the bottom half? I'm going to be at 2 pi. What happens when I go around the top half again? I'm at 3 pi. Because what's happening? Each time you go halfway around, that is 1 pi. Because what's the whole way around? 2 pi? Okay, so I ended at 3 pi. If we went a full way around again, what's the next one that's equivalent? 5 pi. If we go the full way around, yes, 5 pi is equivalent. What's equivalent after 5 pi? 7 pi? 9 pi? Could we keep on going on forever? We could. Okay. So what's the idea there? That all of your odd numbers will be equivalent as you go positive? What about negatives? If we start here and we go negative. So here I'm at 0. When I go negative, what am I at over here? But it's negative 1 pi. Since I went down, it's negative 1 pi. And then if we continue going around, over here on the right is negative 2 pi. Where am I at over here? Negative 3 pi. If we go around again, negative 5 pi. Negative 7 pi. Just like in the positives, except it's the negatives. Is that enough to convince you that negative 99 pi is equivalent? Because I'm not drawing negative 99 pi out. Okay? That's a disaster. But the idea that all of your odds are going to be the same. Okay?
I understand. I think you might have to go through.
Nice try. So, a good thing to know as we work to get comfortable with radians, because that's going to be one of the hardest things we do. You understand 0, and realize the whole unit circle is 2 pi, right? So that means each quarter is a half. Because if the top half is 0 to pi, 0 to 1 pi, that means the halfway point between 0 and 1 is 1/2 pi, which commonly referred to as pi over 2. So you've got 0, 1/2, 1. That means down here it's 1.5 pi, which written as 3/2, and then 2 pi. 2 pi is not listed on this one, but realize that's what it is. And you're welcome to write 2 pi on there if that makes you more comfortable. Okay, questions on what I was doing there? Again, because we're understanding how the unit circle works. Now, there's a side note down there. These angles simply differ by an integer multiple of either 360 degrees or 2 pi, because each time you go around, you're adding 360 or 2 pi. And as it says, because a circle measures either 360 degrees or 2 pi radians. Okay, let's look at example 1. Example 1, they don't give us a picture to work with. I'm not going to draw a picture. You could, but find a positive and a negative angle that are coterminal with the given angle. Okay, stay in degrees. If they're giving me 30 degrees, pi over 6 is the same angle just in radians. I want to stay in degrees. I want another name for 30 degrees in degrees. Another name. Why 390? Yeah. If you're at 30, how do you find the next angle? You're going to add a whole circle. So you're going to add 360. So 30 plus 360 is going to give me 390 degrees. And that is a positive coterminal angle. Yep. In order to get your negative, you're going to take 30 and you're going to subtract 360. Because you can add or subtract 360 as many times as you want. 30 minus 360 is negative 330 degrees. Now realize, are those the only correct answers? No. Because we could subtract 360 again. We could add 360 again to the positive one.
Why would we add it again?
If you had to give more coterminal angle names, more names for the same angle.
So then if you were given a coterminal name, how would you figure out this 30 degrees?
Oh, like if I gave you 390, subtract off the 360. Anytime you're trying to find what it's equivalent to, if you start with a big number, subtract off 360 until it's something that's under 360. Because that's going to tell you what it is on the unit circle you know, or the one you're familiar with. negative 150. I want a positive and a negative coterminal for negative 350. Excuse me, negative 150.
Negative 470. Yeah.
Okay. So if we're going for the negative first, you take negative 150 and you subtract a 360. Negative 150 minus 360 is going to be negative 510. If you want another negative 1, subtract another 360. How do you get a positive 1? You take the negative 150 and add 360. Negative 150 plus 360? 210. And that goes back to the example I kind of mentioned when I was talking up at the top that I guess I used positive 150 and negative 210 are the same angle. But same idea here. Okay. If you don't like that negative 510 and that's presented to you in a problem, add 360. Add it again. Add it till you get a number that you like that's like between 0 and 360. Okay, see, we've got to do it, guys. I cannot always talk degrees. So we will bounce back and forth a lot. 2 pi over 3 radians.
It's up there and it's at 120 degrees.
I'm not talking degrees. It's 2 pi over 3 radians.
So you can't convert that in degrees in your answer?
Well, first of all, they give me radians, so I want all answers given in radians. Okay? If they give me radians, I want all answers given in radians. If they give me degrees, I want the answer given in degrees. Okay, you want to get technical? Could we convert it to degrees, work the problem, and then convert it back to radians? You can, but you're not doing yourself any favors in the long run. You need to learn how to work with radians, which means you need to know how to work with fractions. Okay? And I'd rather you practice that now than be confused later, because we have to deal with these fractions. Yes?
So it would be 4 pi over 3. If you go around a whole time, and then you add 2 pi each time, so it could be 2 pi or 4 pi over 3.
This is where we need to review fractions. You're doing the right thing, but you've got a wrong math in there. Okay, so what did we do on the last 2 problems? We added and subtracted 360. That was degrees. So what do we add and subtract this time? What's equivalent to 360 degrees? 2 pi. 2 pi. And guys, it's right here on your, well, write it on your circle if you want it. Right? Write that in as, okay, that is 362 pi. On the 0. Okay? Where you start at 0 is also 360 degrees or 2 pi. So write that in. It's both. Okay, so we're going to do 2 pi over 3, and we're going to add 2 pi. How do I add 2 pi? 2 pi over 1. We need a common denominator of 3. So what is 2 over 1 in terms of thirds? 6 thirds. Because 2 times 3 is 6, so we're going to be adding 6 pi over 3.
So it would be 8 pi.
So 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. And realize, are you guys realizing the pi's are just along for a ride? It's just kind of like taking an x along. You're just worried about how do we add 2 thirds and 6 thirds. 2 thirds and 6 thirds is 8 thirds. Tack the pi back on. Other way now. That gave me my positive coterminal. Now I have to do 2 pi over 3 and subtract 2 pi. But 2 pi is 6 pi over 3. So 2 thirds minus 6 thirds. What's 2 thirds minus 6 thirds? Negative 4 thirds. So negative 4 pi over 3. I know the temptation is strong to, I'm going to do this in degrees. And I'll, go back and give a radian answer later. I do not encourage that. Okay? Radians is just one of those things in trig you have to learn to work with. If I have a choice, I will try and help you in degrees. But that doesn't mean we don't need to learn radians. Okay. I'll kind of mention it real quick, but we'll have to talk more tomorrow. This was all coterminal angles. So I'm giving 2 names for the same angle. Tomorrow, we will start talking about reference angles, which reference angles are important anytime we're trying to find trig values. So you have to have that understanding. A reference angle is an angle that is a given angle that makes with the x-axis. This angle is always positive and always less than 90 degrees. And always based off of subtracting from 360 to or from 360 or 180. So, it's always positive and it's always less than 90. So if you want the short of it, that means it's somewhere between 0 degrees and 90 degrees. So it's basically a first quadrant angle. Now, where your angle is, quadrant 1, quadrant 2, quadrant 3, quadrant 4, will determine do we add or subtract from 180 or 360. Okay? Because if I have an angle over here, I'm going to want to take it from 180 because this is 180. If I have an angle over here, I'm going to want to add it to 180 because this is 180. If I have an angle down here, this is 360. So I'm going to take it from 360. My first quadrant, those are already going to be reference angles. So that's what we'll talk about. We'll talk about tomorrow. I'll draw some pictures. I will work to make it make sense. And we'll work on it with it on the back side. Okay? Obviously, homework is not going to be due till Friday. And have a good day.